Some questions about fraction came up in the office hours, so what I've decided to do is to give you how the add works, and you should be able to do the rest of the program from that. So when you're done, this is what you should have. You may or may not have this separately, this GCD down here. This is what you're supposed to go look up online. This is the only thing you should look up. Inside it, how to do your greatest common divisor algorithm. This could be packed into your reduce. Maybe it's I made it a separate function. This returns the greatest common divisor of your numerator and denominator, right? So that's what the int is here. This would be your numerator. This would be your denominator probably. It'll find the greatest common divisor of those. And then what do? You take whatever this returns and you divide it into your numerator and your denominator in order to reduce. Then toString, I'm just going to give you the toString. I already have it anyway in this video, so I want to start over. But I did intend to because I want you to see how I did it. I like using string.format. You could also just return, concatenated with quotes. You could just return that. But what it returns is, the numerator / denominator. It might be a good idea to go ahead and get this done so that when you do these, and I don't think I've talked about this in my other videos, so let me do it right now. Whenever you print out an object that has a toString method, and they all do, whether they're overridden or not, this is what you're actually doing. You can do it explicitly. Whenever an object in Java is in a I need to be printed out situation, that sort of thing, it's going to say I need to convert to a string if I can. So let me call my toString method. By default, if you look, I think your fraction test when you run it, it gives you a bunch of gibberish. I think I told you what it was. What is it, the data type and the hash function result or whatever. But if you override it like we just did, it will call this instead. So it'll return something that looks like a fraction. And that's pretty handy. So I typed it out explicitly here. If you run it, you can see it will. And this is, if you look at the array videos, by the way, they're done. So this is all already done. I don't know why it's taking so long to compile. But this is all already done for you. But this is what it looks like. When your fraction test and fraction are done, this is what it should look like. This is what you should see. Test edition. I'm trying to remember if it's exactly the same. 5.6. That makes sense. Okay. Anyway, the toString. You see how the toString was called here because I did it explicitly. But the thing is, you can leave it out. It will be implicitly called. What I just deleted will be implicitly called. Okay. I didn't really mean to do a toString lecture there, but I did. So we'll go with it. Alright, what I told you I was going to show you is how to do the add. And you should be able to do all these three really easily after I show you the add. I also kind of want to show you the constructors in case you haven't seen it. I've got this logic built in. You may or may not. You should really. What I'm doing here is I'm trying to make sure the denominator is never 0 because that's not allowed for fractions. So in the case where somebody tries to they try to create a new fraction that has 0 and, or at least if 0 is ever here, this is what will happen. This is a kludge. This is not the way you really should do it. You do something like create an exception in real life, but you haven't learned exceptions yet. So we're not going to show that version of it. But this is just to demonstrate that you, as the creator of the fraction class, control the state of your fraction. In other words, you try to control anyway, as best possible what values these can be. So the other programmers who are using your fraction class to do like fraction stuff, in other words, whoever, programmer B, programmer somebody else who wrote this fraction test, using your fraction class that you designed, can't violate the rules of how it works. That's the whole point of this. So you might just have, numerator gets N and denominator gets D. That's kind of okay, but really you should have this logic built into. And then the last thing you should do is reduce. So later on, I'm not going to show you how to do that, cherry on top. You'll have a method that will reduce your fractions by, again, finding the greatest common divisor of the numerator and the denominator and dividing into it. on both top and bottom, so it reduces. But notice the cool thing about this is that whenever you create a new fraction, whether it's using this one or not, because notice what this does. I think I showed this with a point, but whenever you create an empty parentheses fraction, what it really does is it calls this one down here with 0 and 1. But regardless, whenever you create any new fraction, it automatically reduces for you. Once you've created that method, you don't have to do the work of reduction anymore. It just automatically does it, because the last step in creating a new fraction is to reduce. It's really nifty. Okay, now let's get to the add. This is what it looks like. You got to cross multiply, and this is the misleading part right here. I think just to get it to compile, I return the empty. I return new fraction empty parentheses. Not the default constructor, but the explicit parameterless constructor. That was only a dummy value to get this to run. So then you could work on it, and you needed to change this return value. I think that might have been the most confusing thing. But you also need to review your fraction math, right? So let's talk about fraction math. In this particular case, what we've got is, I'm trying to remember, because I made a couple versions of this video. I'm trying to remember what I said in this one. Whenever you add a fraction to another fraction, what you're doing, in this case, we're going to use left and right. We're going to use that first example. You're taking 7/12, that fraction, and you're using 7/12 add method to add 1/4 to it. And then what do you get as a result? You get a new fraction object that doesn't exist, and you're assigning it to this answer variable. What is answer? It's fraction data type. Notice it doesn't have a new. It's just, right now it has no fraction associated with it. It's null, memory address 0. In order to use this, you'll need to give it a new something. And the way we do it here is that we return a new from our add method. So just to see that, what I just said, we're returning this, a new fraction. But again, what you want to do is do the math, figure out what the numerator of that new fraction should be, and the denominator, what should it be? And then you create a new fraction based on that. How do you figure out what n and d are, the new numerator and new denominator are? You figure it out by doing the math. So let me show you what's going on here. Imagine that left, the one that's 7/12, it exists in its own universe inside this code right here, right? So for our situation right now, this has the value of 7, and this has the value of 12. Somewhere else in the universe, there's a copy of this code, right? It's exactly the same code because it really is the same class, right? But somewhere else in the universe, there's another fraction. We'll put it over here on the side of the red line that shows us our page width, right? There's another fraction that has 1 for its numerator and 4 for its denominator. So over in this world, because we're calling the add method of the left fraction, the numerator is 7 and the denominator is 12. But we're sending in from this other universe a different object that we're calling that has these values for numerator and denominator. So what that translates to in this code down here is that this, and you could type this dot numerator. I actually prefer to do that most of the time, but for this example, I didn't. But this side, the numerator is 7 here. So just go ahead and do your substitutions, right? The 4, that side is 4. That numerator is 1. This denominator is 12. And then over here, our current denominator inside the left is 12, and that denominator is 4. That's the situation we got going on now. And then you kind of at the same time, you got to remember how I've already done this part for you, but you really should, before you got to this point, you should have reviewed your fraction math. What does it mean to add 7/12, add to that 1/4? The easiest way to do this is not worry about reduction and just multiply the denominators together. And what do you get? You get 48. Then you can cross multiply, which is what I did. You can think of it that way, where you multiply this by this and this by this. Or you can just think of it more logically, like, if this is 48, what does this have to be? What you have to do is you have to multiply your fraction by 1. One way to do that is multiply it by 4 over 4. What's 4 over 4? It's 1, right? If you multiply the 12 by 4, you get 48. So it means you have to also multiply the top by 4 to get 28. So you've got 28 over 48. And same thing for this side, except on this side you have to multiply by 12. 4 by 12 gets 48, and you have to multiply the top by 12. So how do you do that in your code? This is how you do it. You take the denominator of one side, multiply it by the numerator, and then the reverse over here. And you add all that together, and I think what you should get is, you should get 40 over 48. Right? 28 plus 10 is 38, plus 2 is 40, 40 over 48. That's the answer. Now, after you reduce it, find the greatest common divisor. You'll find out that the greatest common divisor, I'm going to forget here, is it 6? 6 times 8 is 48. 6 times, that's not right. 5 times 8 is 40. Yeah, so it's 8. 5 times 8 is 40, and 6 times 8 is 48. So your greatest common divisor is 8. You can divide 8 into both the top and the bottom, and you'll get 5 over 6. 6 times 8 is 48. 5 times 8 is 40. That's the last step. But just to get this part, it's a lot of gibberish on the screen, but you just have to remember your fraction math. Make the numerator of the new fraction you're about to create have 40, right? This n now has 40. Here we go with the zoom. Right click, I can zoom out. Yeah. So once all this math is done, you'll have 40 in n, you'll have 48 in d, and let me dismiss all this. And that means you create a new fraction with 40 here and 48 here, and that's your new fraction. Now, once you build in the reduce, it'll make this will come in. 48 is not 0, so it'll go ahead and assign 48 to the denominator. Your 40 is already in your numerator, so you've got 40 over 48, and then it will call reduce, which will go in and divide both of those by 8 if you've done your reduce correctly. The rest of these should be super easy now. You just have to review your fraction. I think I flashed it too. But review your fraction math and just adapt to this. As a matter of fact, this is a little hint, and I don't know if it's brain warping for anybody, but once you've done multiply, you can use your multiply method to do your divide. Because remember, the way you divide fractions, I don't mind showing you this. This is something you should look up anyway, probably. But how do you multiply 3/4 times, like, say, 2/5? Right? Not the multiply. Forget I said that. Well, we'll do that, actually. 3 times 2 is 6, right? 4 times 5 is 20, and then whatever you do to reduce. But you multiply the tops and you multiply the bottoms. There's no cross multiply or anything. But how do you, instead of, I'm going to just do this. I'm not going to rewrite it. How would you divide? What you do is you flip this. The reciprocal is what it's called, if you remember. You multiply 3/4 by 5 seconds. If you think about that, that means you can use multiply, right? Once you've created it, you just call multiply, this dot multiply, the reciprocal of that. But anyway, you can do that if you want, or just do it like the long-winded way. This is 14 minutes. This might be my longest video, but I wanted to make sure I covered everything, and I didn't want to split it up. So, if you have any questions, don't forget office hours. They're right at the time when I'm making this video. There's office hours tomorrow at 10 till noon. And then, of course, on Monday, it's just due on Sunday, but I know some of you might be a day or two late, which is kind of okay. So, that's it for this video.